Homework.
There's no questions on the homework. We're going to look at the one problem we're going to do today. It's not that it's going to take the whole hour. I just want to look at some that are like this here, that work this way here. It's not overly important, but I do want to show some that are of this type. And since it is only one problem, I did not feel the necessity to print out note sheets for one problem. In small ways, I try to save paper when I can. But so we're just doing this one problem here. Now, the steps for solving it and the ones we've been doing are not different. The first step is there one radical. No. So even them out. Now, we don't necessarily have to even them out. We can. It will be helpful in some ways to even them out. But we can or we don't have to. Both will work. Now, this one here is already evened out. Yes? So we can go on to step 2 to put both sides to the nth power. We'll figure it out here in a minute.
Okay, I need a pencil, or I can just like give you $1 tomorrow.
We'll focus. We'll see here in a minute.
Okay, I'm gonna get a pencil because I just ran away.
Yep, right there on the stack of paper. So we're going to put both sides to the nth power. Now, what is our exponent, our power, going to be? 2. We're going to put both sides to the second power. Now, the left-hand side of this is actually quite nice, because the square root of 2x squared is 2x, as our square root and square would cancel. Now, because it's the square root of x plus 7 minus 1, we have 2 terms. We're going to have to multiply this by itself. Just like if we had x minus 1 squared, where it's x minus 1 times x minus 1, we're doing essentially the same thing here. But instead of just having x, we have a radical. Okay, left-hand side is still 2x. Now we're going to distribute this out. We're going to multiply the square root of x plus 7 times the square root of x plus 7. Well, that's just going to be the square root of x plus 7 squared, which is actually kind of nice because the square root and square would cancel. So it'd be x plus 7. Now our square root of x plus 7 times negative 1 is just negative square root of x plus 7. That negative 1 is really going to just be in the front of the radical. If it had been, say, x plus 7 and this instead of being 1 had been 2, negative 2 would be negative 2 square root of x plus 7. That number is going in front. The only time it would go inside the radical is if it was, say, square root of 2. They both have the same radical. We multiply what's inside. Now we're going to continue on. Negative 1 times square root of x plus 7 is negative square root of x plus 7. And negative 1 times negative 1 is positive 1. Almost. Because this here, I have negative and negative, yes? Well, this is the same as saying negative x minus x, which is negative 2x. So this would be negative 2 square roots of x plus 7. Because if the radicals and everything inside are the exact same, then we can treat them like terms. Now, if one of them had been x plus 7, the other was x plus 3, they're not like terms, they're completely different values. Plus 1. Well, technically we do have one set more set of like terms, which is our 7 and 1, which give us 8. Yes? Questions on this so far? So, any harder than what we've done before? So we've taken care of step 1. We evened them out. Step 2, we put both sides to the nth power, and then we did simplify. Step 3, the one we normally have pretty much ignored up to this point, yes? Step 3 was, are there any radicals left? Yes, there is a radical left. So repeat steps 1 and 2. Step 1, is there a radical? Yes, get it by itself. because we're going to get it by itself, and then we are going to put it to the nth power. So is the radical by itself?
No.
No, we got three things with it. We have x, 8, and negative 2. What do we want to move first? X, and we can do it by subtracting x from both sides. 2x minus x is x, is equal to 8 minus 2 square roots of x plus 7. What can we move next? The 8 by subtracting 8. Telling us that we have x minus 8 is equal to negative 2 square roots of x plus 7. It's neither here nor there with that, but I think it'll be easier for us to see dividing by 2, negative 2. Because it is possible to leave it there, but when we put both sides to the nth power, and again, the nth power is going to be 2, it's not going to just simply cancel with that negative 2. We're going to have to actually apply it to both. So it's sometimes a little bit easier to get it to the other side, but we'll end up putting it back in some ways. We'll see in a little bit what that means. But questions on what we've done so far? Now, it would have been nice if we had 2x or 4x instead of just x. Because if it was 2x, well, then both would be divisible by 2, and that side would reduce a little bit nicer. But that's beside the point. Is the radical by itself? Now we put both sides to the nth power, which in our case is still squaring it. Now this time, the right-hand side's nice, because the square root of x plus 7 squared is going to be x plus 7. I don't need something that big yet. On the other side, well, we have our x minus 8 over negative 2 squared. So we're just multiplying it by its self. Eventually, yes. But not so much at this point. Now, when we multiply x minus 8 over negative 2 by x minus 8 over negative 2, let's do the denominator first, the bottom of the fraction first. Because we're doing negative 2 times negative 2, which is 4. Yeah. That multiplication's nice. Might as well do it first. We've got to distribute across the top. X times x is x squared. X times negative 8. Negative 8x. Negative x, 8 times x is negative 8x. And lastly, negative 8 times negative 8 plus 64. So let's combine like terms before we do anything else. So we have x squared minus 16x plus 64 all over 4. And it would be nice if that did divide evenly, but our x squared is causing some problems, yes? Because what would be really nice is if there was a way to get rid of that 4. And there actually is. We can multiply everything by what? 4. Because what happens if I multiply this side by 4? Yes, if we do it to one side, we have to do it to the other. But here the 4 and 4 would cancel. This is called multiplying by a scalar. And this works with any equation. So I'm just going to write one over here. If we said 0.2 x squared plus 0.6x plus 0.7, if I multiplied all of this here by 10, 10 times 0.2 is 2x squared. 10 times 0.6 is 6x plus 7 is equal to 0, yes? We can multiply it. We've done this before. We did it whenever the x squared term was negative. We multiplied it by negative 1. We're scaling it so that our numbers work nicer. Here, that multiplication of 4 gives us x squared minus 16x plus 64 is equal to, and that's not a 4.
4x.
7.
So 28. 4x.
Because our 4 times x would indeed be 4x, and 4 times 7 is 28. I'm glad I noticed that before we got to the end.
I probably would have noticed it. Wrote it on my paper.
We have a quadratic, yes? So what do we need to do?
Put a 0.
We need to get 0, so yes, we would subtract 4x. Telling us x squared minus 20x plus 64 is equal to 28. And then we would subtract 28. Telling us x squared minus 20x plus. Since the value in front of x squared is indeed 1, there's no greatest common factors, we can graph it. X squared minus x plus 36 is so because again we have two solutions. One of them is because there is one that is at 2, the other is 18. Now, yep, so we're looking for the y value. What value of x will make the y value be 0? Now, there is something interesting with 2 and 18. Because 2 and 18 are factors of what? It's written up there. 2 and 18 are both factors of which number? 36, yes. Because if I was factoring this, we'd end up using the factors of 36, which are 2 and 18. If you looked at most of the ones we did yesterday when we found our two solutions, they were all factors of that constant term. The only time they're not is if, well, they would be, but they would be affected by whatever the first term, a, would be. Because they multiply together to get that. So 2 and 18. And before we call it good, what do we have to do? Check it. Good? So we can do 2 first. Or are you doing 18 first? 2. So we'll do 2 times 2 is equal to the square root of 2 plus 7 minus 1. Well, we can type in the square root of 2 times 2. Well, what is 2 times 2? Square root of 4 is? 2.
Oh, 4. Yeah, square root, sorry.
2 plus 7 is?
9.
Square root of 9. 3 minus 1 is? So x equals 2. We can check 18 as well. Square root of 2 times 18 is equal to the square root of 18 plus 7 minus 1.
Oh, wait, I did not do like that. I put it in the x squared minus 20x plus 36.
So the square root of 2 times 18 is 6. Square root of 18 plus 7 minus 1 is? 4. Well, that's not it.
Oh,
So,
wait, that not the same, so I just put it in the equation that we graphed.
yes,
I
but
just do that. And it equals 0 in the equation. Or it'd be an answer.
so I'm going to back up just a step. Here we go. So here, you plugged it into this one?
Yeah.
So 18. So if we do 18 squared, minus, what was it,
20 times 2.
20 times 18 plus 36 is indeed 0, and that's what it was equal to, yes? Now, when we plug 18 into the equation, 2 times 18.
Oh, that's because it gets to 0. Okay.
Now here, 2 times 18, and we take the square root of it, is 6. Here we get, well, 6 is not equal to 4. So our x is equal to 18 is an extraneous solution.
Oh, okay. So
The only solution for this here is x is equal to 2. So we have to check it in the original problem. Because both do work with that quadratic, they just don't work in the original context. There we go. Questions on this here? All right.